So I'm going to separate a mixture that contains an organic acid, an organic base, and a neutral compound using acid-base extraction. Specifically, I will dissolve a mixture that contains benzoic acid, p-bromoaniline, and phenanthrene in dichloromethane, and then throw it into a separatory funnel. And then I'll add a solution of hydrochloric acid, which will convert the p-bromoaniline into its hydrochloride salt, which can then be removed in the aqueous layer. Once that's removed, I will throw in a solution of sodium hydroxide, which will convert the benzoic acid into a sodium salt, which can then also be removed in the aqueous layer. Once the three compounds are separated, I will convert them all back to their neutral solids.
Benzoic acid is corrosive. Phenanthrene is an irritant. P-bromoaniline is an irritant. Dichloromethane is toxic.
Here I have a 1:1:1 biomass mixture of benzoic acid, phenanthrene, and p-bromoaniline. I'm going to dissolve the mixture in 10 milliliters of DCM or dichloromethane. I'm going to add the solution to a separatory funnel. Next, I'm going to add approximately 5 milliliters of 3 molar hydrochloric acid. Two layers are noticeable. I'm going to cap the sep funnel and shake it to mix the two layers, so the p-bromoaniline that is in the DCM layer will come in contact with the HCl and cause protonation. The p-bromoaniline HCl salt will then migrate to the aqueous layer. I will vent it so the pressure does not build up too much. Shake some more, vent again, shake one more time, and vent one more time. To be safe, I'm going to add a few more drops of DCM and watch where they go, so I know which layer is the DCM layer and which layer is the aqueous layer. You can see the drops fall to the bottom. This makes sense because DCM has a greater density than water and is usually the bottom layer. So I'm going to label this bottom flask with an N, which will be the neutral organic dichloromethane layer. And now I will just drain off the bottom layer, being careful not to get any of the top layer. I'm going to label a second flask AE, which will be the acidic extract or aqueous layer containing the HCl and the p-bromoaniline salt. I will drain the solution into the flask, close the sep funnel, and add back the neutral DCM layer so I can extract it one more time to ensure I get all of the p-bromoaniline out of it. I will add approximately another 5 milliliters of 3 molar HCl. Cap the sep funnel, shake it, vent it, shake it, vent it. Drain off the bottom neutral DCM layer, and then collect the top aqueous acidic extract layer. I will pour back the neutral layer that should no longer contain p-bromoaniline, but still contains benzoic acid and phenanthrene. To remove the benzoic acid, I will add approximately 5 milliliters of 3 molar sodium hydroxide. I will shake the sep funnel to facilitate the deprotonation of benzoic acid by sodium hydroxide, forming ionic sodium benzoate, which will migrate to the aqueous layer. And as before, just to be safe, I will add a few drops of DCM. The DCM, as expected, is the bottom layer. I will label a new flask BE for the base extracted aqueous layer. First though, I will drain off the bottom neutral DCM layer. And then collect the base extracted aqueous layer. I will close the sep funnel and pour back in the neutral DCM layer. Then extract it one more time with approximately 5 milliliters of the 3 molar sodium hydroxide solution. You can sort of see two layers on the sides of the sep funnel, but not in the middle. I'm going to add some more 3 molar sodium hydroxide to see if I can get the layers to be more noticeable. Now I will drain off the bottom neutral DCM layer. And then collect the second portion of the base extracted aqueous layer. So now all three compounds should be separated. The acidic extract should have the p-bromoaniline hydrochloride salt, the basic extract should have the sodium benzoate, and the neutral DCM layer should still have the phenanthrene. So now I need to turn them all back into the neutral solids they once were. I'm going to add anhydrous sodium sulfate to the neutral DCM layer to absorb any water that may be present. You can tell enough has been added when you can swirl it around and it's not all completely clumped together. I will set this aside for now. Next, I will add 6 molar HCl solution to the basic extract, which will protonate the sodium benzoate, converting it back to the benzoic acid. I will monitor the pH of the solution to ensure the protonation occurs. Right now the basic extract has a pH of about 10, and the 6 molar HCl has a pH of about 2. I will know the protonation is complete when the basic extract also has a pH of about 2. I will grab some ice to cool the basic extract before addition of the HCl solution, since some sodium hydroxide is also present, and to minimize the solubility of the benzoic acid. For similar reasons, I will also start cooling the acid extract, and some distilled water to help during transfers. I will add some of the HCl solution and then take the flask out of the ice water bath so it can be seen easier. Formation of benzoic acid as a white precipitate is noticeable. After adding approximately 5 milliliters of the HCl solution, I will now test the pH, which is the same as the HCl solution, and confirmation that all the sodium benzoate has been converted to benzoic acid. I will collect the solid using vacuum filtration. I will wet the filter and attempt to transfer as much of the benzoic acid as possible. I will then rinse the flask a few more times. And then leave the solid to dry on the vacuum for a while. When it's dry, I will collect it on a watch glass and record its mass. Similar steps are used to convert the p-bromoanilide HCl salt back to the free base form. In this case, 6 molar sodium hydroxide is used instead of the 6 molar HCl. And when addition of the sodium hydroxide solution is complete, the acidic extract should have a pH of about 10. After at least 10 minutes of drying with sodium sulfate, the neutral DCM extract, which should still contain phenanthrene, can be transferred to a beaker, leaving behind the solid sodium sulfate and the excess water it absorbed. The DCM may uncontrollably drip out of the pipette. To prevent this from happening during transfer, it can be sucked up a few times to equilibrate the inside of the pipette before attempting to transfer it. To prevent any of the sodium sulfate from entering the pipette, positive pressure can be applied to the pipette bulb until it reaches the very bottom of the flask. To ensure I did not leave behind any of the phenanthrene, I will rinse the flask with a few more milliliters of additional DCM and then transfer that as well. Next, I will evaporate the DCM solution on a hot plate in a sand bath. Instead of a boiling chip, I will add a wood applicator stick. DCM has a low boiling point at 40 degrees Celsius. To prevent burning the solution when there is only a little bit of it left, I will make sure it is no longer in direct contact with the sand. I will also let the very last of it evaporate on its own at room temperature and increase its surface area by rolling it around a few times in a beaker. I can then scrape it from the beaker to a watch glass, and when it's completely dry, record its mass. I started with 520 milligrams of the mixture. I ended up with 100 milligrams of p-bromoanilide, 107 milligrams of benzoic acid, and 145 milligrams of phenanthrene. So the percent recovery was 68%. This value makes sense because I lost some of it during transfers. The highest recovery for phenanthrene may be due to its greater tendency to always stay within the dichloromethane layer, and also it was recovered by evaporation of that layer as opposed to collecting it by filtration using the Buchner funnel.